coming to the background, we have studied in the latitudes, longitudes, rotation, revolution of the earth, that is earth is tilted on its axis, and therefore no place on the earth receives same amount of insolation throughout the year. That is the way insolation varies as per the latitudes. That is, as we go away from the polar regions, as we go away from the equator to the polar regions, the amount of insolation will keep on varying. Maximum amount of insolation is received in the equatorial regions, and after that polar regions में की तरफ जैसे जाओगे, the amount of insolation will keep on varying. So what are these different factors which affect the insolation? So factors affecting the distribution of insolation are, first, one of the most important factor is the angle of sun's rays. The second important factor affecting the insolation is length of day. And night. The third important factor which affects the insolation is perihelion and aphelion. Already. Perihelion and aphelion. Then the effects of atmosphere. Effects of the different factors which affect the insolation: angle of sun's rays, length of day and night, perihelion and aphelion, that is the distance of the earth up from the sun when it is away and when it is near the sun, perihelion when on January 3rd when it is away from the sun, and aphelion because it is near the sun. Why it occurs? Because Earth's orbit is not circular, it is elliptical. Then the sunspots and the effects of the atmosphere. Now look here, will be obviously they can ask you, that is, describe the factors affecting in the insolation. But even in the preliminary examination, the questions are asked from this. For example, why does the sky looks blue in color? You will find the answer in this. Why during the sunrise and sunset the sky looks red in color, reddish in color? You will find the answer in this. What do you mean by vertical sun rays? What do you mean by horizontal oblique sun rays? What is the difference? Why vertical sun rays causes more heat as compared to the oblique sun rays? What are sunspots? How is the sunspots related to insolation? And what is perihelion and aphelion? Obviously length of the day and night. So this are the topics here we'll be discussing, each from both preliminary point of view as well as from the mains point of view. The answer becomes very, very simple. Affecting distribution of insolation, we'll first start from the first factor, that is the angle of the sun's rays. It means whether the sun's rays are more or less perpendicular or they are in a slanting position, they are in an oblique position. That is on the surface of the earth. If this is the place on the surface of the earth, whether the sun's rays they fall in the vertical manner or they fall in an horizontal oblique manner. That is, how much area are they covering? So these are different factors which are affect the sun's rays. Now, one more thing you remember, as you go away from the equator, the angle of the sun's rays goes on becoming more and more oblique. Vertical sun rays are fall on the equator, while as we go away from the equator, the sun's rays become more and more oblique. So here, what you have to remember is the sun's rays are more or less perpendicular or vertical over equator. As we go away from the equator, they become more and more oblique, or they become more oblique polewards. Arrive at the, what do we can say about the perpendicular sun's rays? Now you must be most common play time during the childhood. That is burning of the candle, burning of the paper, newspaper, any paper using magnifying glass and the sun's rays. What we used to do during the hot summer day, we used to take the magnifying glass and put it on the paper so that the paper would burn. Why? How was it possible? Because the magnifying glass used to concentrate the sun's rays over a small area, therefore the heat received on that small area was more per unit area. That means on the piece of a paper which used to receive sun rays in diffused manner, by the use of magnifying glass, you used to concentrate that sun rays on the piece of the paper. By using this magnifying glass, we used to concentrate all the sun's rays on the piece of the paper, into burning of the paper. Now, why did the paper used to burn? Because the amount of heat or energy received per unit area of the sun, of the paper, heat received of the sun per unit area on the paper was more when there was a concentration. Now look at the above. In this above diagram, unit area in, that is the point. or oblique sun rays or vertical sun rays, where will be the more heat received? That is the per unit area of heat received in this region as compared to this region. When the sun's rays are vertical, the sun's rays get concentrated on a smaller area. Because they are getting concentrated on a smaller area, the amount of heat or energy received per unit area of a land gets higher, and hence the vertical sun's rays are associated with high amount of insolation. Therefore, jitna vertical hai sun rays, utna there will be more heat and more amount of insolation. Why? Because of the two factors are related. That means you have to remember that the vertical sun rays, that is the vertical sun rays, vertical sun rays heat minimum area and thus, because they heat minimum area, thus energy received per unit area increases, and therefore vertical sun's rays give insolation. Give more insolation. Now, why do they give more insolation? Because concentration of heat on a smaller area. ज़्यादा से ज़्यादा sun's rays are concentrated on a smaller area, and therefore there is more heat received. And the same used in the magnifying glass, that it used to burn the paper when the magnifying glass was projected on a piece of. That is, the sun's rays was on that piece of a. On other hand, the oblique sun rays, these are slanting, and therefore they spread over a larger area, and therefore the heat received per unit area is less. That is, the heat on per unit area is less because there is no concentration. Dhyan bhatak raha hai. Similarly, the sun's rays are spread over a larger area, and therefore the heat received is less. Therefore, the oblique sun rays are associated with the less amount of insolation and the less that the oblique sun rays spread over larger area, and therefore insolation is less. Now, you remember that the angle of the sun's rays, vertical sun's rays, higher amount of insolation, vertical sun rays, oblique sun rays, less amount of insolation. Now, per unit area is one factor. The second factor is vertical sun's rays travel through less atmosphere because they come in a straight path. On the other hand, the oblique sun rays travel in a slanting manner, so that means they have to travel through large amount of atmosphere, and as a result जितना ज़्यादा वो atmosphere में से जाएगा, there will be more of a scattering, more of a absorption, more of a reflection of the sun's rays by the atmosphere, and therefore the amount of solar energy received becomes less and less, and hence the amount of heat received becomes less and less. That angles of the sun's rays, vertical sun rays have large amount of energy. Why? Because of the two factors. What can we say? Vertical sun's rays high amount of insolation, why? Because first, per unit area second is they travel short distance. They travel the short distance. On the other hand, oblique sun rays less insolation, because one, they spread over large area, and therefore heat received per unit area is less, and second, they travel a lot and therefore scattered, absorbed by atmosphere. Absorbed by atmosphere. Now, what is the importance? Why are we studying this? It is because on the surface of the earth, are more or less vertical over the equator. But as you go away from the equator, they become slanting, and near the polar regions they become more and more slanting. So why do the polar less amount of insolation, in spite in the northern hemisphere, the sun is in the northern hemisphere, the polar regions have 6 months of day, फिर भी वहाँ पे 6 months of day है, फिर भी वहाँ पे why there is no summer season or why there is no heat in the polar regions? It is because of the oblique rays of the sun. The polar regions never receive the vertical sun rays. Why there is more heat in the tropics? It is because the vertical sun rays are received only in the tropics. Therefore, we can see sun rays in tropics. Therefore, heat surplus areas. Polar regions. Heat deficit. Because of this. Obliques are the heat deficit regions. The second, you are all clear with this fact, because very simple fact, and where you can apply it in your own life also. That is, during the summer season, because the sun is in the northern hemisphere, we all get, and as we are staying in the northern hemisphere, we all get vertical sun rays, and therefore too much amount of heat, and therefore we have a summer season. But जब sun नीचे होता है in the southern hemisphere, we call it winter season. Why? Because we get oblique sun rays. We do not get direct sun rays. So even if there is a day and night variation is there, why there is a day and night variation? Because it is all related to the sun and angle of the inclination. But during the winter season, दिन में भी क्यों? Why do we feel cold? Because the amount of insolation does not come straight vertically. It comes in a slanting manner. And jitna it comes in a slanting manner. See, the arrow from or bullet, or even an arrow, if it does not go straight, then it does not have a piercing property. Same thing, if it is going in a slanting manner, then it's no use. It does not have that much fierce power, or it does not have that much killer shot. Though it has to be vertical. Same thing you can apply it to the sun's rays. Vertical sun's rays, more amount of heat, and therefore, whenever areas which receive vertical sun rays, that is the tropics, receives heat throughout the year, it is warm throughout the year. Usme bhi the equatorial regions receive vertical sun rays in a maximum manner throughout the year. Therefore, the equatorial type of a climate is the same type of a climate. That means, din bhar there is a dhoop, दिन भर there is, every day is hot and humid, and every day in the afternoon, due to convectional currents, due to heating up of the earth's surface, there is a rainfall. Now this rainfall occurs because in the afternoon, because heat सबसे ज़्यादा is in the afternoon, therefore it is known as an 4 o'clock rainfall. We'll do it while doing the equatorial sun rays in the tropics. Why are the tropics heat surplus areas? Because of the vertical sun rays. And why are the polar regions heat deficit areas? Because of the oblique sun rays. Now the second factor is the length of day and night. Length of day and night. It is very simple. If there is a duration of a sunshine, during the day, that is more than length of day, high insolation, resulting into heat, more heat. Now if there is a shorter duration of a sunshine, that is more night, or we can say long night as compared to the long day, then less insolation. Therefore, less heat. Of a sunshine, that is longer is the daytime, we get high amount of insolation and more heat. While there is shorter duration of a sunshine, because when there is a long night, less insolation and less heat. Now, in the the sun is over in the northern hemisphere, that is when the sun is over the Tropic of Cancer on the 21st of June, we have summer season in the hemisphere. This happens during the summer season in the northern hemisphere or in any summer season, and this happens during the winter season. Why this happens? Why there is a change in the season? Because during the season the sun is in the northern hemisphere, as we are staying in the northern hemisphere, in the northern hemisphere in the month of April, May, June, July, August, there is a high amount of sunshine because the sun is in the Tropic of Cancer. When the sun is over the Tropic of Cancer, we receive more amount of insolation, there is a larger length of a day, and that is why summer solstice, June 21st, is the longest day in the northern hemisphere, but it is the shortest day in the southern hemisphere. On the other hand, it is the longest night in the southern hemisphere and the shortest day in the southern hemisphere, and we are experiencing summer season, they are experiencing winter season. Why? Because of the length of duration of day is greater. Why the length of duration of a day is greater on the 21st of June? Because the sun is in the north hemisphere. Conversely, or opposite of that, when the sun is in the south hemisphere, when does it occur? We have done it many times. It occurs during 22nd of December, that is the winter solstice. Now it is winter solstice with our reference, that is northern hemisphere mein there is a winter. So on this day we are having the longest night, shortest day, the winter season, and hence, but conversely, hemisphere mein there is a summer season having longest day and the shortest night. So if the question comes in the examination, be very careful with what statement they are saying. They can give you the statement that is the June 21st has the longest day and the shortest night in the northern hemisphere. Yes, it is true. But agar jaldi mein, if the statement is the June 21st is the longest night and the shortest day in the southern hemisphere, where this statement is true or not, if you miss out the southern hemisphere, you may do a mistake in the examination. So be very careful while the examination. Now coming at the central point of the earth, equatorial region. Because the equator is the central part of the earth. Because the equator, 0 degree equator, is at the center part of the earth. So whether the sun is in the southern hemisphere, it does. Equator will have 12 hours of day and 12 hours of night. Throughout the year. Throughout the year. So remember, is in the northern hemisphere or the sun is in the southern hemisphere, the equator will have 12 hours of day and 12 hours of night. North hemisphere, longer days, short nights during summers. When sun is in north hemisphere. The winter. So after the winter equinox, after the equinox, that is when the sun starts going downwards, that is after 23rd September, when the sun starts going southwards. So how do we feel? There is a difference when the sun starts moving southwards. Apne yahan pe in the northern hemisphere, because we are staying in the northern hemisphere, after 22nd of September, we start experiencing decrease in the length of a daytime while increase in the length of comes 22nd of December, when there is a longest night and the shortest day in the northern hemisphere, and we call that as a winter solstice, and we are in the peak of an winter season. So the length of the day and night affects the insolation. And again, very simple, one fact you remember: the sun is in the northern hemisphere, whether the sun is in the southern hemisphere, 12 hours of day, 12 hours of night throughout the year. This is one of the very important facts you will have to remember. Why? Because it is the central part of the earth. No matter the sun is in the northern hemisphere or the southern hemisphere, this part, because of this being the center of the earth, light will always fall and it will experience 12 hours of day and 12 hours of night. Perihelion and aphelion. Now the earth goes around the sun in an elliptical orbit. If this is the sun, the earth moves around the sun in an elliptical orbit. What do you mean by elliptical orbit? The earth's orbit is somewhat like this. So there comes a time when the earth is nearby the sun, and there comes a time when the earth is the farthest away from the sun. Now this, when the earth is farthest away from the sun, it is known as aphelion. When it is nearest from the sun, it is known as perihelion. Perihelion occurs in the January 3rd every year. Aphelion occurs on July 4th every year. July 4th every year. So this is around 152 million kilometers. This distance is around 147 million kilometers. When the earth is nearer to the sun during the perihelion, that is on the January 3rd, we will receive higher amount of insolation as when the sun from the earth, when the earth is away from the sun in aphelion. When is the summer season in India? That is, 4th is hotter. So sun se to earth is bahut dur hai. Then how come it is hot in the northern hemisphere? It is cold in the northern hemisphere when the earth is nearby the sun, when during the perihelion. Now see, we are staying in the northern hemisphere, and this factor, that sun, earth and the sun, that is the perihelion and aphelion, is not that factor as compared to the oblique and vertical rays of the sun, as compared to the length of day and night. This is a minor factor, and hence it does not matter too much. But obviously during the perihelion we are experiencing the winter season, but the southern hemisphere is experiencing summer season, and during their summer season they are nearer to the sun. So people who are in the southern hemisphere, they will experience more severe summer as compared to the people who are there in the northern hemisphere, because fortunately during on July 4th, when there is a summer in the northern hemisphere, we are farthest away from the sun. But fortunately, people who are living near the unfortunately, now people who are living in the southern hemisphere, they are nearer to the sun when there is summer in the northern hemisphere. Now what you have to remember, that this is a minor factor. Obviously, what is a perihelion? In the diagram only you can see the perihelion is when the sun is nearer to the earth, or earth is nearer to the sun, and ephelion is when the earth is farthest away from the sun. Why does this occur? Because the earth's orbit is not circular, it is elliptic in nature, and as a result the earth revolves around the sun in an elliptical orbit. Now remember the dates, and information comes, that is during the aphelion or during the perihelion. During the aphelion, the people in the northern hemisphere gets more severe or less severe. So you can just, a severe amount of insolation, you can just answer it accordingly. But remember, during the July 4th, our summers are not that severe. It is because we are farther away from the sun. But the summers in the southern hemisphere, they are more severe, because this is the peak summer season for them, and we are experiencing the winter season. So the third factor is perihelion, the distance of the earth away from the sun. The fourth factor is the sunspots. And what are these sunspots? These are the dark spots on the sun surface. On sun's surface, which follow which 11-year cycle, which follow or which are completed in cycle of 11 years. That means maximum sunspot after every 11th year. And remember that the sunspots, more the sunspots, more is the insolation. More is the insolation. More is the sunspot, more is the amount of insolation. There are maximum amount of sunspots, we get amount of insolation. Therefore, after every 11th year in the sunspot cycle, when there is maximum amount of sunspots, that is the dark spots which are there in the sun, our summers will be more severe because of the sunspots. So sunspots look in the attachment, very simple part it is, these are the dark like spots on the sun. But you have to remember from the geography point of view, that is the more the amount of sunspots, more is the amount of insolation. The next factor, effects of the atmosphere. Effect of the atmosphere. In fact, The atmosphere is not very clean. It is the thick gaseous envelope covering the earth. It is made of dust particles. It is made up of numerous kind of water molecules, water vapor, etc. Obviously, clouds, etc. It will have some kind of an effect. You all must have experience. जब बहुत ज़्यादा धूल होती है, if there is too much of a dust, it blocks the sun's rays. In fact, volcano, it is very commonly known, volcanic dust can decrease the sun's rays. It decreases the amount of insolation because it covers the sun's rays. Or more commonly, thicker the cloud, if the sun goes beyond the cloud, there is a less amount of insolation. On hot sunny day or during the cloudy sky, you must have seen that there is less amount of heat. Obviously, high heat and humidity is there, but less amount of insolation is there during the cloudy sky. And as a result of this, this is because the effect of the atmosphere. So what is the effect of the atmosphere? Atmosphere absorbs some of the sun's rays, it reflects some of the sun's rays, it may scatter some of the sun's rays. So sun's rays are absorbed, scattered, or reflected. Or reflected. In fact, 100% of the sun's rays are coming. You remember that gases. Absorb 14% of sun's rays. Atmospheric gases absorb 14% of the sun's rays. Now, the second effect is scattering. The amount of the sun's rays which comes, 20% of the sun's rays is scattered. The 20% of the sun's rays is scattered. Sorry. So 23%, sorry, not 27%, 23% of the incoming solar radiation is scattered. 23% of incoming solar radiation is scattered. Now, why does the sky look blue? Is it because the water is blue, ocean water is blue, therefore the sky looks blue, reflection, or is there any other reason? The sky looks blue not because the ocean water is blue. The sky looks blue because the blue light is scattered most, and therefore the sky looks blue in color. So the blue color is due to the scattering effect. In fact, you read the blue light is scattered most, and therefore sky looks blue in color. So the blue color of the sky is due to the scattering. Scattering matlab throwing away. The light which is coming down is scattered away. And the light, we see the blue color because the blue light in the visible light spectrum, you remember the first part of this lecture, the visible light spectrum is made up of different colors: violet, blue, green, yellow and red. In fact, it is the violet and the blue light which is scattered most, but we cannot see the violet light, and therefore we see the blue color in the sky, and there hence blue light, therefore we see the blue color and resulting into blue light, blue color of the sky, scattering of the blue light when the sun is high up. But when the sun is in the horizon, कब होता है sun in the horizon? When the sun is far away. That is why what we call sun is in the horizon. When the sun is in the horizon, what is the color of the sky? Is it blue or is it red and yellow, or reddish yellow or reddish orange? It is reddish orange. Then why do we see reddish orange color sky? It is because all light is scattered except for the red and yellow light, and hence we see reddish and yellow color of the sky. Now again it is due to the scattering of all lights except the red light. Now look here, the fundamental difference. Blue color of the sky is due to scattering of the blue light, but the reddish color of the sky during sunrise and sunset is due to scattering of all the lights except for the red light and orange light. Now look here. When this is what we call sun is in the horizon, that is sun is far away. This is what we call sun is on the top. Where during the sunrise and sunset, sun is very very far away from us. That is, it is in the horizon. That is, it is far away from the place we are living. That is why we are getting less and less light. Agar sun top vertically hota, it would have been proper afternoon, but during the sunrise and the sunset, sun is very far away. And again, insolation part 1 lecture, which light in the visible light spectrum has longest wavelength. What is the visible light spectrum? If you remember, it is violet, blue, green, yellow and red. Short wavelength, longest wavelength. So when the sun is very far away, it is only the red light which can travel that large distance, and hence we can see only the red light. When the sun is on the top, each and every light is scattered except for when the sun is in the top, only the blue light is scattered maximum, we can see the blue light. But because of the shorter wavelength, sun is nearer to us, therefore we can see blue, violet and the blue lights. But violet light is not visible, and इसलिए अपने को blue light दिखता है during when, and hence the sky color is blue. But when the sun is at the horizon during sunrise and sunset, obviously the blue and violet light will be scattered most because their wavelength is less. But they are scattered to such an effect that we cannot see it, as it is very far away and having short wavelength. But the red light, which is having large wavelength, can travel such a large distance and we can see it through our eyes. This can be seen by us. Okay, and as a result of this, so during sunrise and sunset, during sunrise and sunset, the reddish color of the sky is because of scattering of all lights except red light, except the red light. And also, red has highest wavelength. Can travel long distance. Scattering of the light during sunrise and sunset, the reddish color is because scattering of all lights except the red light. Why? The blue color of the sky is due to scattering of blue light. Remember, are you comfortable with this? And remember, don't make simple and silly mistakes in the examination. It may cost a big time in the examination because this does not become a simple or silly mistake. These are the questions, if they come, which you should not make any kind of a mistake. So we are doing the effects of the atmosphere. One is absorption 14%, second is scattering 23%, and third is reflection. Reflection of the sun's rays. Sun's rays. In fact, you remember, which we get, we do not get 100% of the sun's rays which thus from the sun. In fact, only 51% of insolation is received by the earth, and that just 51% or only around half of the insolation can create such a big heat engine in the tropics. Imagine what it would have been had all 100%. Why do we not get? Because of the effects of the atmosphere. We have done the two effects, that is absorption 14%. We have done the next effect, that is scattering 23%, and third is reflection of the sun's rays. The amount of you can say the portion or amount of sun's rays or insolation reflected from a surface is known as albedo. Is known as an albedo. This can be reflected. जितना बड़ा reflection है, उतना less heat is we get. In fact, remember, clouds reflect 27% of insolation. Insolation. Clouds reflect 27%. So we do not get each and every amount of sun's rays. Clouds reflect 27% of insolation, and hence not the entire amount of sun's rays will come. Now, why the 15% comes? We are doing it as a separate topic, that is the heat budget of the earth. Now, what is an albedo? Albedo is the amount of the sun's energy or any ray or any insolation which is reflected by the surface. Now why do we use, or why do they ask us, or why do it is generally asked to wear light colored clothes during the summer season, not black or dark colored clothes? Because the black color absorbs all energy. If during the summer season, if we wear dark or black color clothes, we will feel more heat because it will absorb more of the sun rays and will feel more heat. On the other hand, if we wear light colored clothes, most of the sun's energy will be reflected, feeling of a general, that is, will feel better or cooler as compared to when we wear the or making us more comfortable. So it is expected to wear light colored clothes during the summer season because of the higher albedo. So remember, what is albedo? It is the amount of sun's energy. Lighter the color, it will reflect more amount of sun's energy and there will be less insolation, less heat. Darker the color, it will absorb more amount of sun's energy, it will be high heat and more warm. So clouds, white clouds reflect around 27% of sun's insolation. Coal, dark cotton soil absorb the sun's insolation, making the region warm. Ice, which is having highest albedo, will reflect the sun's energy. So remember, lighter color, high is the albedo. Example is snow. White clouds. So this is the effect of the energy. Now our next topic will be heat budget of the earth. But remember, what are the factors affecting insolation? We have done is the angle of the sun's rays, then second is the length of day and time. These are the two major factors. Then third was perihelion, aphelion, that is the distance of the earth from the sun. Because we are living in the northern hemisphere, we do not feel that much effect. Then is the sunspot cycle, that is after every 11 years there is an increase in the sunspot. Maximum sunspot means maximum amount of insolation. And lastly, the effects of atmosphere, in which absorption, 14% of the sun's rays are absorbed by the atmospheric gases. Then scattering, 23% is scattered. Out of this 23%, some reaches the ground while some is scattered back into the sky. The blue color of the sky is due to this maximum scattering of the blue light, while during the sunrise and sunset, the red color does not get scattered, and because it is having the highest wavelength, it can travel a larger distance and we can see red color in the sun during the sunrise and the sunset, that is during the dawn, the twilight. While albedo, that is the reflecting property of a material, also is an important determinant. One of the favorite questions of the UPSC is, what is the albedo of a cloud? You remember that the clouds reflect the 27% of insolation. Okay, so, and not only of UPSC, of many state services also, or PCS examination, as they are commonly known as Public Service Commission examinations, as they are commonly known as, they also, in fact, they have a liking of asking of factual questions. So this is one of the most common question is, what is the albedo, or how much amount of insolation is reflected by the clouds? So remember, 27%. So our next topic here is the heat budget of the earth. Bit technical, but before that you revise this topic and meet me in the heat budget. Thank you very much.